Now we come to proving the law of cosines, and kind of a similar idea here. You can drop a vertical. I'm going to choose to do this off of B. Now, for every one of the three versions, for the three versions of the law of cosines, you'll drop your vertical differently. So I'm sort of slicing the angle B and dropping down to the base B, and that's going to give me one version. I'd have to do the same thing for the others. And here on C, I'd actually have to go this way, and I'll have to deal with that. I won't cover that in this video, but you just end up with 180 minus your angle, and you can use the trig identities to deal with that. So here we go. When we do that, we'll call this this distance h again, and I can now talk about the cosine. Let's not write in red, that doesn't seem like a good idea. Let's talk about the cosine of the angle A, and well, that's going to be this distance right here, the adjacent over C. Haven't given that a name. Let's call that x, and let's call this part y, and let's note that x plus y equals b. We can see that we've sort of broken b up into these two pieces. Fine, so cosine of A is adjacent, which is x, over hypotenuse, which is c. And so then I can solve for x, and I get x is the c times the cosine of A. And y, I'd like to write y in terms of this. Y is b minus c times cosine of A. Where is that coming from? Right here, I can think of y as b minus x. I just figured out what x was, so plug that in. Excuse me. And you end up, whoa man, you end up with y in terms of cosine of A. All right, so that's that. We did cosine of A. Now let's look at the sine of A, sine of angle A. And I'm going to get opposite over hypotenuse, so h over c. And so I end up with, of course, h is c times the sine of A. That kind of feels familiar. It feels like the law of sines. Now we look at this little part of the triangle. This is a right triangle. And I can use Pythagoras for this triangle. Similarly, this side is a right triangle, and I can use Pythagoras on this triangle, and I can write things down. I actually want to focus on this side, ironically enough, and so let's do that. So we get that h squared plus y squared is a squared. Of course, it's also true that x squared plus h squared is c squared, but I'm not going to need that, so we'll leave that there. Now for h, I'm just going to plug in. I've got y and I've got h in terms of these other things, so I'm going to plug them in. And so h is c sine of A, and that's all squared, so we'll say c squared and then sine squared A, plus y is this b minus c cosine of A all squared, and this equals a squared. And I can maybe feel some of you not enjoying this part very much, but that's okay. We're just going to expand it all out, so we're going to get a c squared sine squared A plus, what do we get here? B squared minus 2bc cosine of A plus a c squared cosine squared of A, and all that is a squared. Now I'm looking, hoping something will clean up here, and notice these two terms, c squared sine squared and c squared cosine squared. That adds up to c squared, right? You factor the c squared out, sine squared A plus cosine squared A is 1. And so I end up with just a c squared. So I have c squared plus b squared minus 2bc cosine of A is indeed a squared. And that is a version of the law of cosines. That's one of the three. And you play the same game for the other two. And that's how you do it.